Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? Today we will start with the new chapter. It is Matrices. The first thing I want to say, please remember about our linear programming problem because that lesson and with this matrix they have the connection. Okay, the first we will talk about basic concept and types of matrix. Okay, in basic concept, in here we saw the picture of the car. Three cars dealer itself three model of a car. The table showed the numbers of car each dealer sold in a given month. Dealer 1, dealer 2, dealer 3 selling the model A, model B, model C. Look, you can see in from this table. We can organize data like this in a matrix. So you can put any variable in here, but remember when we calling about the matrix, they using the alphabet, the caps lock A. So this one is because the model A in the other one is 5, so 5, 7, 4, 3, 4, 9, and 2, 0, 1. Okay, so this matrix we can see has 3 rows and 3 columns. Row is 5, 7, 4 and the column is 5, 3, 2. Okay, the column is 5, 3, 2 and then the row is 5, 7, 4, everyone. Okay, definition. Definition of matrix is a rectangular arrangement of numbers in row and columns. Okay, so we can see from here, we have the rows, the row A11, A12, A13, dot, 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 until A1N. And then we have the columns, A11, A21, A31, dot, 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 and until AM1. Okay, so from here, we have, we can see M rows, and then we can see N rows. So from here, we know that if the horizontal lines of the number in the matrix are called rows, and then the vertical line of the numbers in the matrix are called column. The number of rows and the number of columns determine the dimension or order. So if in the matrix have the number of the rows and the number of the columns, they call it dimension or order. But for easier, sometimes we call this order. Okay, so from here, M by N, XN, we can say it M by N, the matrix with M rows and then the N columns. So the first before the by, we are using rows, and after that we are using the column. Okay, each number in a matrix is called an entry. What's the entry? Entry, we can say A11 is entry, A22 is entry, and then AMN is still entry. So the member of the member or the element of the matrix, we can say entry, everyone. Okay, example 1. We can see in here A close 254630. So from here we can see they have 2 rows because 254 is first row and then the second row is 630, right? But in here they have 3 columns. What's the column? 2, 6 is 1 column, 5, 3, 2 column, 4, 0 is 3 column. So we can say this matrix A is 2 by 3 matrix. 2 by rows and 3 by column. Okay, in here, in there, like I said before, we have entry. Okay, so A13 is the entry of the element of A13 is the matrix A. So in here, 13 is that the showing, 1 is from the first row, and then third is from the column. So we can see first row is 254 and then the third column is 4. So this one is equal with, yes, correct, is 4. How about number 3? This is the explanation. A13 is the entry first row, and then the third column. A13 is 4, so you need to connect them. Okay, everyone? Okay, there is a type of matrix. The first is square matrix. Square matrix is a matrix which has some number of rows and columns. Let's say 1 by 1, 2 by 2, 3 by 3, and then etc. So this is the example of the order 1, and then this is order 2. When you find they have the same dimension or the same order, you just can say it's 2. But when you find the dimension like 2 by 3, you should say it 2 by 3. It's not the same with the just 2, okay? Okay, from here, they have 2 rows. The first row is 1, 0, and 4, 2. And then they have 2 columns, 1, 4, and 0, 2. So this one is called, yes, dimension 2. How about this one? This one, they have a 3 dimension or 3 by 3. So we just can say it dimension is 3. Okay, we said that a square matrix has order n if it has n rows and n column. Like I said before, if they have some number of rows and column, so we just can say it order n. Okay. Number 2, rectangular matrix is a matrix with different number of rows and columns. So from here we can see they have 2 rows and then 3 columns. The rows is 1, 0, 3, and then 4, 2, 2, and then for the column is 1, 4, 0, 2, and 3, 2. So this one is 2 by 3. So this one is rectangular matrix. And then this one, we can see they have the 4 rows. So the first minus 1, 0, 2, the second 2, 0, 7, the third 3, 1, 8, and then the last 2, 5, 6, and then they have 3 columns, minus 1, 2, 3, 2, 0, 0, 1, 5, 2, 7, 8, 6. Okay, so the number 3 is row matrix. Row matrix is a matrix with only 1 row. So this one, minus 2, 4, 8, 0, 3. This one is only 1 row. But they have another, they have more than 1 columns because they have minus 2 first column, 4 is the second column, 8 the third column, 0 the fourth column, and then the 3 is 5 column. And then the column matrix is the same with the explanation about row matrix. They just have 1 column, but they have more than 1 row. So this one is 9 first row, minus 2 second row, and then the 1 is the last row. So this one is 3 by 1, everyone. Okay, the 5 zero matrix. Zero matrix is a square matrix whose the entry are all 0. All of the member or all the element is 0. So we can write zero matrix as null to mean zero matrix. Identity matrix. In identity matrix, a square matrix whose main diagonal element from top left to bottom right are 1, whose other element are all 0. So in here, so if they have just 1, is the order 1. So this one is calling still identity of matrix because what? Because the element or because the entry is 1. Okay, but for another number, not. How about the second identity? The second identity, we can see that, okay, identity matrix is, we can say identity matrix, the first, if they have the main diagonal element is the, from the top left to bottom right are 1, and the order n. You need to remember the order has the same with the column and the rows. This one is from top left to bottom right. So 1, 0, 1, 0. So another element is 0. How about the third? So we have this one is the order 3, and then they have the 1, and then the other elements are all zeros. They are still identity matrix, everyone. So we write the identity matrix with the symbol I. Okay, don't make it wrong with the 0, 1, 1, 0. This one is not identity because, okay, the rules, they have two rules, right? The first rule, they need to have the same row and column. Okay, they have the same. This one is the same row and column number, but they doesn't have top left to bottom right for the elements 1. So this one is not identity. Okay, 7, diagonal matrix. Diagonal matrix, a square matrix in which all the entry except the main diagonal entry are 0. So let's see. Okay, the main diagonal of a square matrix always run from top left to bottom right. That's it's calling main diagonal. So this one, okay, let's see. A matrix in which all the entry except the main diagonal are 0. Okay, except the main. Okay, this one we can say this one is diagonal matrix, but they are not what's the say in diagonal matrix, not 0. Okay, how about scalar matrix? Square matrix whose main diagonal elements are equal, A11 equal A22 equal A33 equal, and whose the other element are all 0. Okay, this one 8, but this one you can say this one is not identity because it's 8. Scalar matrix, they have the same from for the main diagonal the same value, or the element the same with the main diagonal. So -5 to -5, 7, 7, 7. How about number 9? The number 9 is symmetric matrix. If all the entry in the square matrix with the respect to the main diagonal, AMN equal with the ANM. How it can be? Okay, we can see in main diagonal is different, right? And then, but you can see in here, the first row, and then the second column, this is 2, and then the second row and the first column is 2. So they are have the same. How about in here? They have the same 2 and 2, 0 and 0, 5 and 5 is symmetric matrix. How about anti-symmetric matrix? If the at the entry of the main diagonal of square matrix all are 0, and sum of the symmetric entries with the respect to the main diagonal are 0. So this is the example. Okay, when we calculate for 2 plus -2 is 0, so this one is anti-symmetric. How about 1 plus -1 is 0? Okay, so this one is 0. This one is anti-symmetric if the main diagonal are 0. And then when you another entry you want to sum, and then the result is 0, is the anti-symmetric. Okay, the triangular matrix. If all the entry either above or below the main diagonal of square matrix are 0. Okay, this one. We can see from here if the above is the below is 0, so this one is triangular matrix, and then the left side, the above is 0, so this one is triangular. Triangular divided by 2, the first is lower, and then the second as up here. Lower, this one 0, 0, 0. Well, how to know it says lower? Lower when they have the value in the bottom, and then up here when they have the value. So this one upper triangular matrix. So the last is communication matrix. A matrix shows the paths of communication between different things placed or points. So now let's jump to the example. Example 1. Let A have a matrix with the element 4, 2, 5, 3, 4, 2, 6, 1, 3. So you need to find the dimension or order of matrix A. Okay, so from here we can see that if they have how many rows? This is the first row, second row, and then third row. Okay, third row. So this one is, we can say 3 by how many columns that they have. So this one is 1 columns, 2 column, and then the 3 column. So this one is 3 by 3. So this one we have 3 by 3 dimension or order. Okay, everyone? I hope you understand. Okay. Number B, write the entry in second row. Second row. Okay, this is first row, second row. Second row is in here. So write the entry. So the entry is 3, 4, 2. How about write the entry in the first column? First column in here, 3, 4, 4, 3, this one, it should be to go down, 4, 3, and 6. Okay, how about the D? They're asking about find the A13. So A13 is the meaning first row, 3 columns. Okay, first row in here, 3 columns, 3. Okay, so this one is 5. How about A33? So this one is 3 row and 3 columns. 3 row, and then 3 columns. So this one is 3. How about A21? A21, it's the meaning 2 rows and 1 column. 2 rows. 2 rows and then 1 column. 3, 2, 3 again. How about A32? A32, 3 row, 2 column. 3 row. This one is 3, 2 column in here. So this one is 1. Okay, everyone? I hope you understand what I'm explaining. Example number 2. Write the A2 by 3 matrix where A and N is showing that there are entry such that A and N equal with M plus N. Okay, so from here we have the A2, 3. 2 by 3 is that the meaning they have 2 rows and they have 3 columns. Okay, so we make it this one first. A2 by 3 it's equal with 2 rows. And they have 3 columns. A11, A12, A13, A21, A22, A23, right? They have first row, second row, and then they have 3 columns. First C, second C, and then the third C, right? Okay. After this, you need to find what the element of A11, A12 until A23, right? So they give us A and N equal with M plus N. Okay. A and N equal with M plus N, everyone. So from here we have the A11. A11, 1 is showing M, so plus N, so it's equal with the 2. So the element of the A2 by 3 is equal with 2. How about another? Okay, now we find until the rest to get the matrix. How about 8, 1, 2? The one is M plus N is 2. So this one is 3. How about A13? A13 it's equal 1 plus 3 it's equal 4. Okay. How about A21? So this one is 2 plus 1 it's equal 3. How about A22? 2 plus 2 it's equal 4. How about A23 equal with 2 plus 3 equal 5. Okay, everyone, if this one is general term, it's anything. So you must to see this one clearly, what's the element in here to find this value. So from here we get the matrix 2 by 3 is 2, 3, 4, 3, 4, 5. Okay, everyone? I hope you understand. Given A equal minus 3, 0, 5, square root of 3, 1, 3 over 2. You need to find 2A13 minus 3A square 2, 1 minus 4A23. Okay, so from here you need to find first is A13. Okay, A13 is that the meaning first row and 3 column. Okay, first row, 3 column. First row, 3 columns in here. So it's 5, the value. How about A21? A21, 2 row, first column. 2 row, first column. So they are meeting in here. So this one is square root of 3. How about A23? 2 row, 3 column. Yeah. 2 row, 3 column. So the value is 3 over 2. Okay, so we get the A13, A21, A23. So you need to find this value. To find this value, you just need to substitute them. A13 is the value 5. And then A21 is the value square root of 3 because it's 3 times square root of 3 minus 4 times 3 over 2. So this one is 10, 9, 6, right? 1 minus 6 is minus 5. So this one is the value from this, everyone. Okay, I hope you understand. Example, the arrows in the figure at the right show the direction of communication in a network computers. Write the matrix to show the communication path in the network. Okay, everyone. Because in here, they just is possible or not possible. What the meaning possible? Possible is the direct from the one computer to another computer. So we can give them is 1. The one is if possible direct network, direct communication is we get the point 1. But if they are not possible, it's 0, not possible. Okay, so from here we can see the connectivity of the ABCD computer to computer ABCD. Okay, computer A, to computer A, it's not possible except they have direct to another computer and then they will come back to computer A. It's possible, but in here we are talking A to A is not possible. So we give the point they are 0. How about A to B? They have connectivity in here. So this one is value 1. How about A to C? The value is 1. How about A to D? It's impossible. So 0. It's possible, but A to D, they should jump to the B or jump to the C, and then they are reach the D, right? But from here, we want to know the there, right? B to A, they have direct, so this one is 1. How about B to B? It's impossible, so 0. How about B to C? They have connection. B to D, they have connection. How about C to A? C to A, they have connection. How about C to B? They have connection. How about C to C is 0. How about to C to D? It's connection. Direct connection, I mean. And then, how about D to A? D to A is 0. D to B is 1 from here. D to C 1 and D 0. Okay, so from here we have the matrix 0 1 1 0 0 1 0 1 1 sorry 1 1 0 1 0 1 1 0. So this one is matrix 4 by 4. Okay, everyone, I hope you understand what I'm explaining today. Write the communication matrix P to represent the following network. So from here, we have A, B, C, D, E. So we have the 5 to 5. So we have A, B, C, D, E. A, B, C, D, E. Okay. So from here, A to B, it's 1. Oh, sorry. A to A. There's no A to A, it's 0. A to B, it's 1. A to C, it's 1. A to D, not connection. A to E, not connection. B to A, not connection. There's no rule. B to B is 0. B to C, no. B to D, yes. B to E, yeah. C to A, yes, 1. C to B, 1. C to C is not, 0. C to D is 1. C to E, 1. Okay. How about D to A? D to A is 0. D to B is 1. D to C 0, D to D 0, D to E 1, E to A 0, E to B 0, E to C 1, E to D 0, E to E 0. So this one is the matrix 0 1 1 0 0. 0 0 0 1 1 1 1 0 1 1 0 1 0 0 1 0 0 1 0 0. So this one is matrix 5 by 5. Okay, everyone, I hope you understand. Thank you for today. I hope you understand what I'm explaining. Please more exercise. I have tasks, so you need to work with your tasks. So thank you. Assalamualaikum warahmatullahi wabarakatuh.